Hey grade 12, back again. This time we're looking at chapter 9.4. It's going to be a slightly longer video. Now before I go any further, if you haven't watched my introduction to annuities video, please go and do that now, okay? Because in this video I'm not going to be overly explaining too much what an annuity is, okay? That's what the previous couple of videos were. Now this might seem like a bit of repetition, but it's still good to see multiple pieces of setting out, particularly for a new area of mathematics for you. Okay, so to start with, we've got using the annuity future value formula, which is this one here. Calculate the future value of $500 invested every 6 months for 10 years at 6% compounding 6 monthly. Write your answer correct to the nearest cent. Okay, so we've got our formula here. Let's just go through and substitute everything. So what we're trying to find is our amount from the future annuity. Now, M is the amount per period. So the amount per period that we're going to be investing is $500, okay? And that's taken from right here, okay? I'll highlight it for you. Now, it's invested every 6 months for 10 years, okay? What we're going to be able to find from this bit of information is our N value, okay? Particularly because it compounds at the same period, okay? Compounding 6 monthly, we deposit it every 6 months. You'll find for these questions, they'll always align, okay, grade 12? Now, what we've got every 6 months for 10 years, that's going to give us an N value of 20. How I arrived at that is because if we do something for 10 years every 6 months, N will be 20, okay? Now the only thing we need to fill in is our I value. Just realised I shouldn't have filled it in on the one up here, my apologies. The I value, now 6% as a decimal is 0.06. If you just write 0.06, however, you will be incorrect. That is 6% every year, but our compounding rate is 6 months. In 6 months, you are not earning 6% interest, you are earning 3%. Now, how I found that is I just divided it by 2, okay? And I'll probably just rewrite it here, that's okay. So 0.06 divided by 2. Okay, and when we plug this in to our calculator, we will get our final answer. So that's what I'm going to do just now. I'm going to take my calculator and put this in. Please make sure you pay special attention to where some of these brackets are, okay? And if you're not getting the answer I'm getting, it means that most likely you are not using brackets appropriately, okay? Or you might have the minus in the kind of wrong area. So just trying this now. Seems right. I'm just making sure I haven't made a mistake with my brackets. Nope. So I get a future value, deleting all this, of 13,435. To the nearest cent would be 19 cents. Okay, so what I'm going to do now is just write that as a summary. Okay, there is my final answer, okay? And I always like to do a good little estimation. He's depositing, in this case, well, they're depositing $1,000 a year. 1,000 times 10 will give you 10,000. We're definitely over the 10,000. That seems about right, okay? Particularly for compounding only every 6 months. Now, the second one here, calculate the annual contribution needed to obtain $50,000 in 10 years. Now, straight away, we're still doing a future value because we want to know how we get to $50,000. But in this case, we know that A is equal to 50,000. Okay, in 10 years at 4.5% per annum with interest compounding annually. Now that's going to make our N value equal to 10 because 10 years compounding once a year, 10 times 1 is just 10. Now our rate in this case is just going to be 0.045. We don't need to divide it by anything here because as you can see, it's per annum and it compounds annually. So 4.5 divided by 1 is just 4.5, which is 0.045 as a decimal. Now, in order to solve this, okay, here it's m times. Okay, so what I'm actually going to do is move it to the other side and make it a divide. Okay, now I'll use my divide sign here, and that is going to be equal to m, capital M, sorry. All right, so I've just moved that to the other side. Now, you can just put this straight into the calculator as it appears, and it will give you your answer. Okay, and that's going to give you, oopsie, so m, let's calculate what it's equal to. So I'm doing 50,000 divided by what appears in the brackets, all to the power of 10, take away the 1, and then we are dividing that by 0.045. Okay, might have just made a mistake in mine. Probably forgot a bracket. There we go. I ended up with a value of $4,068. So $4,068. Okay, $4,068.94 for that one. Doesn't say to the nearest dollar, so 2 decimal places is always good. Center that again. Okay. Therefore, a yearly contribution of $4,068.94 is needed to achieve a future value of $50,000. Now, some of you might be going, well, hang on, sir, wouldn't we just want to find the present value of that annuity? And that's not the case at all. Because remember, when we're finding the present value of an annuity, that's like a fire and forget scenario, okay? That's where we just invest it in one account and never put any more contributions. But in this case, we know what we want to end up with. We need to find the monthly deposit that we're going to be making into that annuity. And that's exactly what we've done here to get our $4,068. Just to double check it, if you times that answer by 10, we get a total of $40,000. We know we're going to end up with over that, 50, so seems about right. Okay, on to the next one. Okay, just get rid of some of the space here. Using the formula for the present value of an annuity, so I've already put that there, that's just taken straight from the textbook. Determine the present value of an annuity of $1,500 per year for 10 years invested at 5% per annum. Hence, in the context of this problem, explain the present value. Now, the one thing I don't like about this question is it doesn't actually have the compounding period. So, seems to me like a little bit of an oversight. You know, we're not trying to trick you with a lot of these questions, okay? So don't be afraid of that, all right? Now, I'm going to make the assumption that this compounds every year, okay? It's an assumption because the question doesn't give it to us. So now we go through and let's substitute. We know that our M value is going to be 1,500 because that's how much we're frequently depositing. Now, that's every year and it's over 10 years. That's going to make our N value equal to 10, all right? Okay, 10 years compounding once a year, 10 times 1 is 10. Okay, now that just leaves us with this I value to find, and it's 5%. So we don't need to divide it once again. The reason we don't need to divide it, sorry, as I just enter these, is because it's 5% per annum, and we already made the assumption that it compounds every year. Now remember, you can only make the assumption when the question doesn't specifically answer that for you. All right, I'm just going to sub that in. Now this one, you've got to be careful with the amount of brackets you put, okay? Very easy to make mistakes with this one. I'm just going to quickly go in, sub all of this in. That's divided by 0.05 times 1.05 to the power of 10. Okay. So what I end up with is a present value equal to $11,582.60. Okay, doesn't have anything about rounding, so again, 2 decimal places is always relevant here. Now, I'm actually just going to quickly double check my answer. Now, the way to double check it, okay, is to take this information that we have here and substitute it into a compound interest formula. So $11,582.60. We're going to multiply that by 1 plus our rate, which is 0.05, and that's to the power of 10. Okay, I end up with $18,866. If I go back now and check the future value of that annuity, they should all line up. So 18,866 is what I end up with, and that should be the value of the future annuity, which is what I'm going to check now, times 1.05 to the power of 10 minus 1, and dividing that by 0.05. And yep, 18,866. So there is our present value. And what that means is, if we were to follow through with this annuity, if we didn't want to do the annuity, we could instead, at the very start, deposit this amount of money into a bank account at the same terms, forget about it, and they'll both arrive at the same future amount in 10 years' time. Okay? So I'm just going to put that in there for... Now, again, for the exam, they're probably not going to be super in-depth, but I think annuities are really important to understand because it really gives you that insight on, how, say, a home loan and reducing balance works, how superannuation works. It's just really good to have that understanding. Okay, next up, Genevieve's grandparents set up a perpetuity to help pay for her tertiary education. They invest $125,000 at an interest rate of 4.5% per annum, with the interest rate for this perpetuity compounded quarterly. Okay, so here we go. Calculate the amount Genevieve can pay off her university fees each quarter. All right, so we don't know the M value. What we're going to do is take this perpetuity formula and we're going to substitute in. Now, the amount that we have is $125,000. We don't know what M is. That's the amount she's going to receive from this perpetuity. The interest rate in this case is 0.045. Now, if you were to sub that in as is, you could technically do it this way, and what you'll get is an amount every year, but we don't want that, okay? What we want is we actually want an amount every quarter. So we're actually going to divide this by 3. Now, we can do this because it compounds every quarter, and I would strongly suggest doing it this way, and it's every quarter, so it should be 4. Sorry about that. So, rearranging it, what we're going to get is the following. Just copy and paste this down so we can see it. Here, it's going to be a multiply now, because the opposite of dividing is timesing, and I'll express this as a fraction. And that's just going to equal M. Okay, so rewriting it, making M the subject first, and then I'll just write the answer as well. M, just putting the numbers into the calculator now. 125,000.045, divide that by 4. I end up with an M value of $1,406.25. Now, what this M value means is, while this $125,000 is sitting in a bank account generating interest every 3 months, because that's when it compounds, every 3 months it's going to generate a compound interest amount of $1,406.25. Now, what Genevieve can do is she can go to the bank every 3 months and go, okay, I'm going to take out exactly this amount of money. Now, what that does is effectively like a soft reset on the interest loan. It will then go back and calculate interest on just the $125,000. We're not giving it a chance to rise exponentially like a compound interest account should. But that's okay. That's the whole point of a perpetuity. They set a certain amount of money to the side and they use it to pay small kind of amounts or dividends, if you want to think of it like shares, to help pay things off. Now, her grandparents want Genevieve to receive $2,000 each quarter, and so decide to shop around for a better interest rate. Calculate the interest rate that is needed to ensure a quarterly payment of $2,000. So again, we start with our A equals M over I formula. Now, the difference in this case is we still have $125,000. Sorry about that. What's going to happen now is we need to find the interest rate per quarter. And I'm just going to write that here. Keep in mind this is per quarter. This time, the amount we want to receive from this perpetuity is $2,000. Now, to rearrange it, this is what we're going to end up with. So 125,000 down the bottom here. And moving the 2,000 to the other side, you're going to end up with this. Okay? And what that's going to give you is just the interest rate per quarter. All right, so backspace on that. Okay, so that's how we get our interest rate per quarter. So copying and pasting this down. Sorry, zoomed out a little bit. Make I quarter. Sorry, little I. The subject, and now just putting that in. I ended up with a rate of 0.016. Now keep in mind that's for every quarter. If you want to find the interest rate per annum, which is what I'm about to do now, we just simply multiply it by 4, don't we? So interest rate per annum, multiply that by 4, which gives us basically 0.064, which is 6.4% per annum. Okay? Let's get rid of some space here. I forgot to put my summary statement for the one above, so I'll do that while I'm here as well. Therefore, her grandparents would need to secure a loan at 6.4% per annum to receive $2,000 a quarter. Okay, and there's my summary statement for that one. All right, for this one, therefore, Genevieve would receive $1,406.25 every 3 months, or that's every quarter, as I said earlier. And there we go, guys. We've got our 2 summary statements for that. Thank you very much for watching this video. I'll space them out a little bit so they all kind of fit on the 2 pages. Yeah, look, there we go. Awesome. Well, thank you so much for watching. Hopefully this kind of helped with the annuities, both present, future, as well as perpetuities. Any queries, as always, just let me know.